everyone, Seth Kitchen here with a new series for developers or soon to be programmers or whatever you want to call yourselves. This series is going to be on everything from computers to Python programming to data science. And what kind of sparked the interest for this is I just got an invite to Yandex's, which is kind of like the Google search of Russia. They just invited me to a data science class. And I'm going to take it to see, if I'm missing something in my knowledge, which I probably am. And along the way, I can teach you guys things that I already know, plus the things I'm learning in the class. And so the first lesson I'm going to teach about is computers in general. So you might already have a general knowledge of computers, or you think that you're an expert in computers, but not necessarily programming. And I'm going to make sure that you understand that before we even jump into the intro tutorials of Python, which would be the next kind of course. So let's start with, let's say you want to buy a computer, right? What's the first thing you're going to tell Amazon what you want? Maybe you're like, okay, I want either a desktop computer like a tower, or I want a laptop, right? And I want to make sure it's new. I want to make sure it's within the last year, because I know technology goes out of date a lot. So I went ahead and went to Amazon, right? And I typed in 2020 laptop, and this was the first one that came up. So let's dissect what's in these keywords here. So the first thing we see is 2020. So we know, oh, this is brand new. This is going to be super nice, right? We're going to see Dell, which is the brand, right? So maybe you're like a super big Apple fan, or you're a Microsoft fan, or you have some other brand that you love. Well, maybe you're a Dell lover. I've never heard of a Dell lover, but that's what brand this is. So that would be something, if I don't think it really necessarily has a big play on the computer as a whole, but it doesn't have any effect on if you're comparing computers side to side, but maybe that's what you would look into if you have a favorite brand. Okay, and we see it's a Latitude, which is just what they're calling it. Latitude 5500 is the model number, right? So this still has nothing to do with how great this computer actually is. Okay, so I've learned nothing except that this is from 2020, so it's new from Dell. That's all I've learned from these first few keywords. Okay, now the next thing is actually kind of useful as far as if I want my stuff to look good on my screen, because that's what this is here, is 15.6 inches. So this is the screen size from one corner to the other corner. The diagonal across the screen is going to be 15.6 inches. So that's averagely big for a laptop. I guess you can get a better grasp of how big that is from these images on the left. So if you're looking for a huge screen, maybe that's not this, right? But as far as programming and what we're going to go into, that really has no play in this. As long as I can see what's on the screen, I don't really care how big the screen is. But again, if you're, maybe an artist, you want a big screen with 5K resolution, maybe you also need to look at if it's FHD here. So if you're an artist and you're looking for something huge, what you're going to want to see there is that it's a 5K screen or that's a 4K screen. And sometimes those aren't even listed that way. They're listed with these HD symbols because they don't want to say how bad it is, right? So FHD is actually very bad, right? So we have UHD, which is, Ultra HD, which is pretty much the primo that you're going to want to look at. FHD is one step below that. And so I'm pretty sure it goes FHD, then UHD, then 4K, then 5K. Maybe someone can correct me, but if you want the best of the best screen, you want it to be really big inches here, and you're also going to want it to be list 4K, 5K, or UHD. The FHD actually shows that this screen is actually pretty bad. So I would not say that the display here is going to be knock your socks off. But again, we don't really care about that. We care about the processing, because that's what we're going to be programming with later on. So if we look at the next thing here, it's the processor. And so the first thing I say is it's Intel, right? So there's two big players in the computer processor world, right? There's AMD and there's Intel. So again, it's Apple versus Microsoft thing. Who are you a fanboy of, fangirl of? You're either a fan of Intel or you're a fan of AMD, and you're going to go with that processor. If you don't care, you don't care. Like for me, I like Microsoft stuff. I like Apple stuff. I like Intel stuff. I like AMD stuff. But depending on what you go with, you can compare the specs against each other to see which one is actually better. And that comes here with the gigahertz. Before I talk about that, though, there is one difference between Intel and AMD, and it's that Intel has this sort of concept of hyper-threading. And what this means is it lists quad core here, and what you're able to do with Intel is multiply those cores by 2, and because hyperthreading basically allows one core to act as two cores. So this potentially will have 8 processors in this machine. So what I'm going to talk about with one single processor for this machine, you're going to be able to multiply by 8, right? So that's on here. So just because that's Intel, if this was AMD and it said quad core, you should only expect 4 processors. So for Intel, if it says quad core, you can expect 8. If it's AMD and it says quad core, you can expect only 4. Okay. So, but besides that, there's not much difference between Intel and AMD. There's also like Snapdragon, who's the brand maker of phone processors. But as far as laptops and computers go, you're probably only going to see Intel or AMD. Okay. So again, the core thing is whatever I'm about to say about processors, which is what's coming next. You can multiply by 8 because it's quad core. Okay, so i7 here means it's the 7th generation of all Intel processors. So again, you don't really get a lot of info from that. Okay, same thing with 8665U. Okay, so it's a version number. So maybe you can compare it against maybe what Intel says is 8000U, and you can expect it to be a little bit better because it's a higher number. But it's not actually telling you a spec here, at least as far as I know. So you can't really learn a lot from i7 8665U. Now what you are going to learn everything about the processor is from this 4.8 gigahertz. Okay, and so I'm going to go into depth with that with a little picture here. Okay, so if I draw a processor here as just a single box, what this processor does for a computer is it does the calculation. So imagine that it's doing 2 plus 2. Okay, and then I'm going to put this number here they have, which is 4.8 gigahertz or GHz. Okay, what this means is, let's start with 1 hertz, right? So if I have 1 Hz, that is 1 calculation per second. Okay, so how fast can you do 2 plus 2 like that, right? Well, I say, hey, what's 2 plus 2? I might have to wait a second before you shout out 4, or if you're wrong, you say 5 or whatever. But if you say the right answer and you're only doing it in a second like that, that's 1 hertz. You just did 2 plus 2 at 1 hertz, right? This computer is gigahertz, right? So a giga is times 10 to the 9th power. Right? So this is 4.8 times 10 to the 9th hertz. 4.8 times 10 to the 9th calculations per second. So if you can imagine, it's doing 2 plus 2 in this processor 4.8 times 10 to the 9th times per second. Okay, so as you can tell, this computer is way faster than you are. No matter what you do with your 2 plus 2, even if you're like super fast, you do it in half a second, right? You're not coming anywhere close to its speed, which is 4.8 times 10 to the 9th times per second. So computers are very fast, and that's why they're useful, because they can do calculations like that so fast. And as I mentioned before, this processor is quad core, which means it can do this many calculations per second times 8 times. So it's just even a bigger number, right? So the computer is super fast. So when you're comparing processors, you want to look at the gigahertz. And so if I see a computer that's 4.7 gigahertz, I can see that's going to be a little bit slower than this computer that's 4.8 gigahertz. So you should try and get a number that's as fast as possible to get the best computer possible. Okay, so I guess you can also look at the number of cores, like I said. So if you find something that's a octuple core, right? That has 8 cores, but again, it's Intel, so it has 16 that it's actually able to use, 16 processors. Then that's going to be better than a quad core 4.8 gigahertz, because you're going to have 16 times 4.8 gigahertz rather than 8 times 4.8 gigahertz. So the two things you should look at in your processor when you're comparing them from computer to computer: the number of cores and how fast they are. Okay. So I think that's enough about processors. So let's move on to the second part, which is this 32 gigabytes DDR4. So what this is talking about is the RAM in a computer. Okay, so this is one step out from the processor. Right, so it's probably represented as a bigger square, right? So as you move out in a computer from part to part, the most central thing is the processor, right? It's going to be the fastest. It's moving at this gigahertz, right? So if you think about the next step down, it's going to be RAM, which is still really fast, but it's probably like 3,200 megahertz. Okay. So this is how fast, instead of how fast it does the calculation, this is how fast it transfers data back and forth, right? So how did we get this 2 plus 2 here in this processor? the two twos that are done, and also the addition operation that want to be supplied to this processor, are being provided by memory around the computer. Okay, and the closest thing to the processor as far as memory goes, well, there is cache, which is an extra level that we won't get into. But the closest thing out from the computer that's mentioned in this description is RAM, right? So it's this box here, okay, and it's telling you that it's got what 32 gigabytes of DDR4. Okay, so this 32 gigabyte is telling you how much stuff it can send to this processor, how much room it has to keep stuff in before it sends to this processor. So if you imagine that it's sending the 2, the plus, and the 2, so it's sending the 2 as the first number, it's sending the plus as the operation that's going to occur, and it's sending the 2 as the second number. Those are things that need to be stored here. So this will also have 2 plus 2 listed in here. It can't do the calculation though. It has to send it to the processor for the calculation to actually occur, but it can store the numbers or the things that need to happen before it sends it to this machine, right? And you want the speed at which it sends things back and forth to be fast, and you also want there to be a lot of space here so that you can continuously send things to it fast, right? And so what you're going to be looking for to make a computer faster is have more RAM and also increase the speed of the RAM as well. So let's talk about why you need more than just RAM as memory in your computer. Okay, so you can think of this kind of like libraries and bookshelves, right? So if I don't want to have to, if I'm reading a whole bunch of books, right, this is good data for me, I want to learn stuff, right, I'm going to have a bookshelf next to my bed where I can go grab a book anytime I want to read that book, learn the information, process it, and then return the book back to its shelf, okay? Well, maybe my bookshelf has full of books that I don't need anymore that I've already used. Well, then I want to take those books back to the library, which is an even bigger selection of books, but that I don't need right now. It'd be a waste to have it there, and I don't have enough space on my bookshelf to have everything that's in a library, right? So that's the best analogy I can give for why you need more memory than just RAM and the processor cache. So let's say that I've run out of my 32 gigabytes of space in this RAM. I need to go back to the library and switch out some things. So let's see how big the library can be, right? So that's the next level. So we just talked about RAM, which is this 32 gigabyte DDR4. So we should mention DDR4 is just another version number, right? So you had DDR1, you had DDR2, you had DDR3, and I'm pretty sure those correlate to how fast. So I put 32 hertz there, 3200 megahertz there. So maybe DDR1 was probably only 1000 megahertz or something like that. So we're at the level where DDR4 is much faster than DDR1 was. But you can look at that number and pretty much tell, okay, this is better than DDR3. Okay, done with RAM now. Let's move on to ROM, or the actual big memory chunk of the system. Okay, so if we look at 1 terabyte versus 32 gigabytes, you can see that the library, which is this SSD, has a lot more room, right? It has 1 terabyte rather than just the 32 gigabytes. Okay, so that's what, almost 1,000 times bigger than the space on your bookshelf. So if you think my bookshelf is 1/1000th of my library size, okay, this can store more information, but it's much slower. In fact, they don't even list the speed of the hard drive because it's so much slower than RAM. Okay, so when a processor, before it gets the information, it first goes from the main memory, or the ROM, which is this 1 terabyte. It gets transferred to the RAM, at which you can't have all of the ROM information in the RAM at one time. You can only have 32 gigabytes. So you transfer some of the information from this big library to your bookshelf, and then your bookshelf goes to you when you're like reading at night, and you return it back to the shelf, and then it goes back to the library. So it's that whole process back and forth again, transferring information. So you're going to want a big library. So you're going to want this library size to be, or ROM size to be, as big as possible. So 1 terabyte is a lot of space, right? But maybe 2 terabytes, that'd be doubly as big. 4 terabytes is quadruply as big. It's how big do you want your library here? So those are the numbers you should be looking at when you're buying a computer. You want a lot of memory, you want a fast processor, and you want a lot of library or ROM space. And that kind of decides how good this computer is. So I mean, if we compare the price of this down here, $1,400, if you go search on eBay or something like that, you can find something that has even higher gigahertz, higher RAM speed, and more ROM space for less price. You're obviously going to want that instead. And honestly, those probably exist there. I honestly, for me, $1,400 for this laptop, I don't know if it's worth it. But then again, you compare it to a MacBook or an Apple product, they usually have way less spec than a Dell machine, but it's way higher price because again, people are fanboys or girls and they want an Apple computer because there's just something about the design or something like that. So let's do an Apple laptop and compare real quick before we end this. All right, so we get a comparable one, which is not even a laptop. That's 1,800. Let's see if we can find something that's closer to 1,300. All right, just for giggles, we're gonna do one that's this 2,000 here. Okay, so if we look at this MacBook Pro, right? This one is 13 inches. I don't know if you remember the last one was 15.6 inches. So that's the screen size, right? From diagonal across. And you're like, oh, well, again, the screen size doesn't matter. Plus, the MacBooks usually have a nicer screen. Like it's not FHD. It's probably 4K or 5K Retina display, right? It's better display, but it's a smaller screen, okay? Then you look at the RAM, right? So the other one had 32 gigabytes of RAM. This one only has 8 gigabytes of RAM. So you can see it's 1/4 the bookshelf space that the last computer had, right? So that's not good. That's way less value. And then you have 512 gigabytes, which is about half the size of the library of the last computer, right? So you can see that it's not double, but it's getting up there to almost be double the price of the last computer, and it's probably only half as good. But it's an Apple brand product, so everyone assumes that it's way better. So I didn't talk about some other things involved with computers like peripherals or graphics units, graphics cards, or anything like that, because we don't really need those to understand what's going on with the computer as far as the tutorials I'm going to be going through. We might talk about graphics cards when we go into deep neural networks or something like that. But for just understanding the basic concepts of programming, those are the three things that really matter when you're programming. So hopefully that clears up any confusion about what a computer is actually doing and what all these things mean when you're buying a computer in general. So with that, I'll end the video. Thank you guys so much. I hope you enjoy this first video of the series.